No. They're by definition, a cation's always a positive ion. So like the beryllium +2, we would call that a cation. If it were beryllium -2, we would call that an anion. Yep. Good question. Yep.
Can hydrogen have, like, be a positive cation?
Cation.
Yeah, but like, it would have no negative charge at all.
Yep. In fact, it's quite often it happens in acids. Acids give off a hydrogen ion and give up, it's essentially you just give off a proton because the electron stays and it gives off a H+ ion, which we won't talk about acids in this class, it's chemistry, but yes. It's kind of weird to think about that it's giving off something that has no electrons, but yeah, it's possible. Okay, so I know it's hard. This one, is it a cation, cation? What is it? Cation. Think of cat.
Yeah.
Cats have paws, so it's positive.
Yeah.
That works, right? That'll help you remember, won't it? Okay, good. Ooh, yes. An ion, this is the definition of an ion right here. And you should have that on your vocab sheet, which I need to give on our vocab sheet. These are all the vocab words for this chapter. There's a backside to that.
Where's the test?
What?
When's the test?
Probably next week. Yeah, early next week, I would guess, if I were to take a guess. Okay, it depends on how much we get through, what we, yeah. So I can't give you a specific date, just a general horizon, probably early next week. Okay? So, let's see if we can remember this. What is the mixing heat of particle motion called? Go ahead. Diffusion, yes. Good. Mr. French touched that, right? Okay. A molecule consists of atoms chemically bonded together. True or false? Raise your hand. True. Okay? True. Very good. All right, there's our new homework, which you already got, correct? You didn't get it in? Should have just showed you right away. I should have just had you all do it now. So what we're going to start doing this section is we're going to start taking this matter idea, all right? What's the definition of matter? Yeah, anything that has mass and takes up space, okay? We're going to take this really big, broad word, matter, and we're going to start breaking it down into more specific things, okay? So you will need to leave yourself some space for a flow chart. You know what a flow chart is? Maybe. So at the top will be matter. We're going to break it down into two things, and we're going to keep branching down. Does that make sense? Okay, and you have to figure out where the best location for this is going to be, because we're going to have vocab words and we're going to continue to add to this branch. Does that make sense? So if you want it all in one spot, you got to think about how you would do that. Does that make sense? So essentially we'll have some word there, we'll have that, like that. I'm trying to think if we go any deeper. I think we might go one deeper. So it'll look like that, just so it gives you an idea of how much space you need. Make sense? Okay? So, we should get done in no time here. I don't think this is going to be, start with that. Pure substance. Let's find that guy. It Because it contains only one kind of matter, I'm going to give you another word here. Some kind of particle, just so you get familiar with hearing that word. Oh, guys, I can tell you something funny. Remember when I had this and we put food coloring in here, right? And it was heated up water? Well, I left it on the whole weekend.
It evaporated.
Yeah, it evaporated, and I don't know how it didn't shatter my glass. So I'm sure what's kind of cool. Well, actually, we'll talk about it today. It's not pure water that was in here. First of all, it had some food coloring. Second of all, what's in water that makes it not pure? Do you guys know? What did you say?
Bacteria.
Well, it could have bacteria, but I'm more talking about stuff.
Oh, it had.
It had. Well, the water we drink is called hard water. Have you ever heard that? It has ions in it. And that usually magnesium ions and a couple other ions, calcium ions maybe. So if you look at the bottom of that, can you see it? You can tell there's some stuff that's left behind. Everybody see that? You ever seen, what is a drinking fountain, right where it comes out of a drinking fountain, what does it look like? It looks like this, right? And sometimes it'd be green. Like if you come over here and look, man, I'll make you come, but some of you might be able to see on the surface that it's like got some solid stuff that seems to be forming on the tip, right? Okay, that's ions that are solidifying out. And we're actually going to talk about mixture at some point today. So I'll give you a little example for that. Okay, particle. Let me describe what I mean by a particle. First, it says only one kind of matter, one kind of particle. This could be a variety of things. Let's just start with the very first thing that could be pure. We could say I have pure lithium. That means all I have is lithium atoms, correct? Okay, that's one type of particle, but it's not the only kind of particle. Could I say I have pure water? But pure water is made up of multiple atoms, but it's together chemically in one type of what? Particle. It's just a bigger particle. Does that make sense? But it's all together that it's still one particle. So if I have all H2O, for example, assuming there wasn't any food coloring in here, and assuming there wasn't any ions in there, and it was pure water, it would just be all H2O molecules. We would call that a pure substance. Does that make sense? You can name any other thing. As long as I only have one kind of particle, it could be an ion. It could be a bunch of beryllium ions. As long as that's the only thing that's in there, it's pure substance. Make sense? Okay? One kind of particle. Can those particles be big or small or you name it? Yes. But the point here is it's just one kind. Okay? So, on our flow chart. We're going to break up matter into pure substances and one other thing here as we progress. You'll have to figure out how you want to organize this in your notes. We're going to continue to add definitions as we go and continuing to fill out this flowchart. All right, move on. They would do that. All right. We're actually going to go further on with this. Let me sit here and check something out. Alright, I don't know if I really like this definition, but what?
All atoms aren't the same, so you could have different numbers.
Well, that would make it an ion.
Well, I mean, like, they had like the same amount, but it was just like this one has 6 electrons and protons, this one has 4.
Well, then it would be a different element. Yeah, I'll explain. So So a lot of times people use the words element and atoms interchangeably, which I understand why. They're so closely related to each other that you can kind of use them interchangeably, but they're not exactly the same. An atom is the particle itself. It's the whole idea that it's got protons, neutrons, and electrons, right? The element is the type of atom it is. Okay, so think of like elements being the flavor and atom being the ice cream. All of it's ice cream, but it's just different flavors, if you will. For example, hydrogen, the smallest particle that you have for a hydrogen would be an atom. Its name, we call it the element, what? Hydrogen. Hydrogen's the name, the atom is the particle itself. Helium. Helium would be the name of the element. If I was talking about a helium element, its smallest particle would be an atom. Make sense? If I'm talking about potassium, that's the name of the element. It's got an atom that makes up that particular element. It's kind of difficult because a lot of times even I will probably use elements and atoms kind of interchangeably, which is fine. They're so closely related to each other that it really doesn't make a whole big difference. But, so a type of pure substance would be an element. And if you want to put atom underneath it in parentheses, they're so closely related, I'm fine with that. Compounds. Does this definition look familiar? Yes, no, maybe so? I'm hoping the answer is yes. The question is, what does it look like? Looks like a molecule, doesn't it? Okay. Not sure you need to know this yet, but I'm going to kind of bump you guys up to chemistry students for a second. Can I do that? All right. Okay. So compound, this is the correct definition for a compound. When you have two or more, it could be the same too, it doesn't have to be different, but we're going to assume that they have to be different. Okay? Chemically bonded, that's called a compound. I can get more specific. A molecule would be more specific. You don't have to write this in. This is just purely for your enjoyment. Okay? A molecule is bonded a specific way. It's bonded covalently. The other way, a compound could be bound, called a formula unit, and it's ionic. Now we will talk later on about covalent and ionic. We are going to talk about this, but I'm not going to make you know at this point what a formula unit and a molecule is. So the difference between a compound and a molecule is a molecule is specifically bonded a certain type of way. Okay, and we'll talk about this in a much later chapter. So compound would be the big, anytime you've got two or more things chemically bound together, that's compound. Okay, all those things are compounds, not necessarily are all compounds molecules. Okay? Next level there for you. So that's what it would be over here. Compound. All right, so let's just kind of give a couple examples of each of these, see if we understand what they are. Can anybody give me an example of an element or atom? What was that? PB, lead, plumbum, yes. Do you know that?
Yeah.
Do you know that it comes from the Latin word plumbum? Plumbing from your bumming?
I think it meant that.
Lead pipes are what connect the toilets. You'll never forget that again, will you? Okay, give me another.
For an element, AU or gold.
Ah, yeah, you got my gold. How about see you at the copper mine? We didn't catch that. See you is copper. You're like, okay, don't get it?
Yeah.
Now you do, right? See you.
I got it when you said I was like.
Okay?
But
All right, compounds. This might be a little trickier. I gave you one earlier today.
Water.
Water.
Table salt.
Yeah. You might know what the chemical formula for table salt is. I should put table salt because anything that's ionic is considered a salt. Not like I'm gonna beat you up, but a salt.
That's
Scarlet.
That's
Sorry, I like to be punny.
That's Pierce.
Third one. Keep coming with the third one.
Kool-Aid. Water.
That's probably a mixture more than it is a pure substance. Like the powder that makes up Kool-Aid. I'm sure it's like sugar and some other thing. Anything? I mean, there's billions of compounds, guys. I don't. Oh, yes! What did you say?
Carbon dioxide.
Carbon dioxide. Anybody know the formula for that?
CODX.
CO2,
Oh,
H2O, and ACO. Now notice the difference between the elements and the compounds. What's the difference? Yeah, right? You have more than one kind of atom that makes up a compound or kind of element. Hydrogen and oxygen. There's two of them that have to be chemically combined. Sodium and chlorine, carbon and oxygen. Those are chemically combined. These are just lone atoms. Got it? Okay. Woo! Moving on. I probably didn't leave myself a whole lot of space for the rest of it. Hopefully you guys did. This is important, though it's really subtle. It says have the same, so compounds have the same ratio of elements. What does that mean? Curious. What does that mean? It has to have the same ratio of elements. You probably know, just can't articulate it, but it's what? I mean, yeah, but that's not.
At least two.
What?
There's at least two.
No.
That it always has the same amount of atoms.
Yeah. So H2O or water is always two hydrogens to one oxygen. Every time. Otherwise it'd be something different. H2O2 is not water. You wanna know what that is? Yeah. Hydrogen peroxide. You ever heard the joke about a guy goes in, get water, says I'll have some H2O, his friend comes behind him, says I'll have some H2O2, and he dies.
Wow.
It's important. Ratio is important. They're the same. I know, that's funny, buddy. Alright. You don't have to put this in your flow chart. This is just some more, I do want it in your notes. There are two types of compounds, and these two types are huge areas and fields of science in the chemistry realm. I took a whole year class called organic chemistry. Have you ever heard that class before? It is the weed out class if you want to be a doctor. You know know what I mean when I say that?
Don't want that.
It tells all the students who want to be doctors but aren't either one, smart enough or don't work hard enough, you can't make it. If you can get past organic chemistry in college, you can do anything. I don't mean you can make it through med school. Is it going to be easy? No. But it kind of separates the serious ones from the ones who want to be. You know what I mean? Who's our class? Very hard. Thankfully, I had a really good teacher. I never did take inorganic chemistry, although I feel like most of all the other chemistry classes we took were inorganic because organic is the specific class. In fact, most of the stuff we will talk about will be inorganic. Water, table salt. Okay. Organic is all life stuff. Got it? Moving on, I'm not going to spend too much time talking about this. Organic has to have carbon. I can't tell you how many things in this world are carbon-based. Those trees outside, like 80%, oh, I shouldn't say that. Most of what makes up the wood of that trees is carbon. Well, I mean, there's more than just that makes things at different densities. But yeah. Okay? Organic is really the study of all living things, and carbon is very, very necessary. It's the fundamental building block of all life. Okay? I'm almost done here. Mixtures. And now we're moving to the other side of the flow chart. Alright, so one side of the flow chart is specifically one kind of particle, other side is now I have more than one type, so I have multiple pure substances mixed together. I don't know, maybe you guys don't think this class goes by very fast, but man, it goes by really fast.
48.
It's like 6 minutes, 5 minutes. Cruises. Well, I hope so, but you know, I guess I can't expect all of you to enjoy every little aspect of what I teach. I realize that. But I don't know, studying gas creation, that's cool to me. Should be cool to you too. Alright, so we got pure substance on one side, big thing, one kind of particle. So mixtures are a mixture. It is, I'm using the definition to define it. A mixture would be taking two or more of those pure substances and mixing them. Okay? Give me an example. There's 100 you could probably give me, but any idea? Anything that's not pure. Except the water we get out of the tap. Got ions, got all sorts of things in there. That's a mixture. I took sand and put marbles in it. That's a mixture? It is. Kool-Aid, mixture, sugar, powder, mixed in the water, yeah? Okay, here's the very important thing I want you to get. Physically placed together. Because if I take and I evaporate all the pure water out, what's left behind?
Nothing.
That's no, you can't. Can you see there's stuff in the bottom of that, right? You can see that?
Yeah.
Okay, that's the ions that have come out of the mixture. I can physically separate them. Can I physically take marbles out of the sand?
Yeah.
Okay, they're not chemically combined. That's important. Okay? What? Okay, a compound, these are chemically combined. Mixtures are not. You can physically break them apart. I can physically take sugar out of water if I evaporate off the water. Okay? No set ratio. Here's what I mean. Remember how we said these guys, there's always 2 hydrogen for every 1 oxygen? Every single time, otherwise it's not what? Water. Okay, could I have a different amount of marbles in my sand?
Yeah.
Could I have more sand in one situation and more marbles in the other situation? They both be still mixtures, right? Okay, so there's never a set ratio for those guys. 2 types. We're just going to define it. How about that? Here you go. You can okay, here, I'll let you. If you want, go ahead, put this in. This will fill out the rest of our flow chart. We got homogeneous and heterogeneous, and it should help us with defining these types of mixtures if we know what the word homo and hetero means. Uh-oh, political correctness here. What does homo mean? What does the word homo mean? Guys, you don't know what homo means? Well, think of a homosexual. What's really unique about that? Guys, it's part of what's going on. We probably should know what it means. What does homo mean? So same. Yeah, homo means same. Hetero means different. Ah. Homo means same, hetero means different. I think we have this and one more slide. We can push through and get this. Okay? Homo, hetero. That's kind of the key here. Is you cannot usually tell by looking at a homogeneous mixture that it's even a mixture. I'm going to keep you a little bit long here. I apologize. Examples of homogeneous mixture. Anyone? While you're writing? You can't visually tell that it's a mixture. But you know based on what some other information that it's a mixture. Anybody? Kool-Aid. That's a mixture, but can you look, if you looked at Kool-Aid, if you didn't know what Kool-Aid was and you looked at it, would you know it was a mixture? No, one uniform phase, looks like one thing, but it is definitely a mixture. Another example, the air that we are in right now. That's a mixture. It's a homogeneous mixture. Can't see the different parts, but we know nitrogen, oxygen, carbon dioxide, you name it, makes up the air. Okay? So a homogeneous mixture is the same, they're the same size, and that's why you can't specifically see the difference. Last thing, sorry here. I want to get you the last one. And then get this in, and you may leave this would just simply be, you can look at it and tell it's a heterogeneous. So the example I gave you of sand and marbles. Can you tell?
Yeah.
Different phases, you can tell. Anybody know what Italian salad dressing is?
Yes.
Okay? Definitely heterogeneous mixture, right? You've got your solid spices in your liquid oil. Other examples, vegetable stew. You got a whole bunch of different kinds of vegetables in a liquidy broth. It's all right before you eat. I'm sorry, guys. Wood might be a little bit harder to tell, but you can see the different wood grains. Concrete, made of gravel and Whatever the stuff is that helps hold it together, I forget. What is that?
Wet sand.
Okay, this should be it for the notes. I will start the day off tomorrow by reviewing specifically this because we didn't spend a ton of time talking about this. Cool?